We did it! We're on our very last part of Unit 1. After this lesson, we'll do a few things in class, and then we'll have our very first test of the year. So the kinetic particle theory is one of my absolute favorite theories. I just love this because it explains so many things in our world. It's explained so much. And it's really simple, actually. So basically, the kinetic particle theory says three things. The first one is, it states that everything that has matter is made of particles. And these particles are always in motion. It doesn't matter if it's a solid, a liquid, or a gas. Anything that has mass has particles, and these particles are always moving. Even in a solid, the particles are just vibrating in place. However, the higher the temperature, the faster the particles move. The lower the temperature, the slower the particles move. So if you heat something up, the particles are going to move faster. Or think of it like this, when you run in gym class, or you just go out running, or you play a sport, you've been running a lot, you've been moving faster. How does your body feel? It feels warm. The faster you move, the particles start to move faster, and that's what that warmth is. So, what's really cool is that this explains why things expand when they're heated and shrink. They contract when it's cooled. The only exception is water. Water actually expands when it freezes. Nothing else does that. But it's true, it's really cool. It's called thermal expansion and thermal contraction. So if we just have this, we'll just take, say, a piece of metal, this square here. When it gets hot, the particles start to move faster, and because they move faster, they hit each other more often. They collide, and when they collide, they start to expand. They start to push off each other, so it expands. So when things get hot, they expand. Now think of it like this. On a hot summer day, and you're just really, oh my God, you have no air conditioning or something like that, what do? You lay out. You try to lay out as much as possible. Why? Because you're trying to cool off. You just expand out. However, the opposite's true when things get cold. When things get cold, the particles slow down and they become contracted. They shrink. Okay, so this piece of metal, when it gets cold, the particles slow down and it shrinks. Think like this. When you're really, really cold, don't you kind of shiver up into like a little ball? Your size shrinks. So, again, kinetic particle theory, everything that is made of matter has particles that are always in motion. When these particles get heated, they go faster. When they get cooled, they slow down. Also works for a thermostat. If you have a mercury or an alcohol thermometer, when it gets warm, the reason why the alcohol or the thermometer goes up is because, again, as it gets hotter, the particles move faster and the liquid expands. And when it gets colder, the liquid contracts, it shrinks, and that's why it moves down. 3. This is common sense too. Heavy particles move slower than light particles at the same temperature. So think of this. I mean, it makes common sense. Well, let me talk about this and I'll see why it makes sense. So, for something to be a solid, the particles have to be moving very slowly and get close together. Now, for that to happen, either it's really cold or it's really heavy. So, again, ice. Ice is a solid. Why? Because the particles are really, really slow. Okay, because ice is very cold. And because the particles are moving slowly, they're very close together, and we talked in the last lesson about attraction. And when things are very close together, the attraction is much, much more. So it becomes a solid. And then as you heat up ice, the particles move faster, which means they're going to move farther apart. So for something to be a liquid, the particles have to be able to flow. The particles are moving faster. And then for something to be a gas, the particles have to be moving very fast. So either A, the particles are very, very hot, or they're very, very light. So number 3 really explains solids, liquids, and gases at room temperature. Why is air, with all these different gases that make up air, why is that a gas? But my phone, which is the exact same temperature as the air, is a solid. Well, it makes sense, because the particles that make up my phone are much, much, much heavier than the particles in the air. And because the particles that make up my phone are so heavy, they move very, very slowly. And because of that, there's this very strong attraction, which makes them solid. the particles in the air, because they're so light, they move very, very fast. And when they're very, very fast and far apart, guess what? There's very little attraction between the particles. And that's what makes it a gas. But I can turn air, the gases that are in air, into a liquid. How? You make them much, 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 much colder. Now, you can do that if you like blow up a balloon and put that in liquid nitrogen. There's some videos on YouTube that show that. You can turn solids into liquids like metal. A metal is a solid, but if you heat that super, 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 super hot, the particles, because they're super, super, super hot, go faster, faster, and faster, and it turns into a liquid. So kinetic particle theory, man, it explains everything about solids, liquids, and gases. Again, there's three main parts. One, everything that has matter is made of particles, and these particles are always in motion. Now, the next two talk about that motion. The higher the temperature, the faster the particles move. The lower the temperature, the slower the particles move. Or you can say the slower the particles move, the cooler they're going to be. Or the faster they move, the higher temperature they're going to be. 3. Heavy particles move slower than lighter particles when the two particles are at the same temperature. Okay, and you can see here another little visualization. In a solid, the particles are very, 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 very close together because either A, the particles are cold, or the particles are very heavy. And then, as those particles either become lighter or become heated up, they'll start to move farther and farther apart because they're moving faster, faster, and faster, and it turns into a liquid. And again, as they become lighter, or they get much hotter, they move even farther and farther apart, so that attraction is much, much weaker, and it becomes a gas. And that's it for kinetic particle theory. I did see, I didn't watch it yet, but I saw there was like a 90-second video on YouTube about kinetic particle theory, so I thought we'd watch that together. And let's just see what that's about. Oh, actually, let's do this video first. This one I did see. This is about mercury. So mercury is a metal, but it's a liquid metal at room temperature versus a solid. Again, why? Well, even though this metal is the same temperature as other metals at room temperature, because the particles are lighter, it's a liquid. It doesn't have that attractive force versus other metals like copper. Oh, my phone's ringing. I'm not going to answer that. Okay, so again, that explains that at same temperature, lighter particles move faster than heavier particles. So again, whoa, that's not what I want to do. That's all I want to do. Thank you. Here's it says animation. It's about 90 seconds, so I thought we'd check that out. Apparently it's about pirates and horses. I have no idea how to say that word. Scamera? What is that?
The kinetic molecular theory is the theory that all matter is made up of atoms and molecules that are always moving.
I told you that.
These particles hold kinetic energy and move around in random directions.
I already said that.
In higher temperatures, the particles have high
What is
energy.
that?
And in low temperatures, the particles have less energy. The more energy a particle has, the faster it will move. In solids such as ice, the particles hardly move at all and hold a regular pattern because the energy is low and the particles are tightly packed. In liquids such as water, the particles have more energy and the freedom to move around. Liquids have the ability to flow and fill the shape of any container they are put in. In gases like steam, the particles have the most energy. These particles are sparse and move around freely. Gases are usually invisible to the eye and they can be expanded and compressed in different pressures. All matter is composed of atoms and molecules that are always moving. The higher the temperature, the more energy these particles have. And that is the kinetic molecular theory.
Oh my gosh. Well, that was something else.